Hi guys, here's our math problem for today. Find the value of x given the equation 16 raised to x plus 20 raised to x is equal to 25 raised to x. This is a difficult equation to solve because number one, the variable is in the exponent, and number two, the root of this equation is an irrational number. But I'm going to show you the technique on how to solve this problem. But first, you can pause the video and check if you can solve this equation. Now let's solve this problem together. The first thing that we're going to do is we'll divide the first term by itself, and we'll divide the rest of the terms by the same value, 16 raised to x. Now any number divided by itself is 1, and so the first term is 1, and we just copy all the rest. Then let's simplify this further. Notice that 20 and 16 have a common factor of 4, but we cannot just cancel that out unless we can separate 20 raised to x into two exponential numbers. Let's rewrite 20 first as 4 times 5. So we now have the quantity 4 times 5 raised to x, and then for the denominator, we write 16 as the quantity 4 times 4, and then raise it to exponent x. Also, 25 can be written as 5 times 5, so we write it as 5 squared raised to x, and the denominator is 4 squared raised to x. Then let's recall some properties of exponents. First, notice that this quantity 4 times 5 raised to x is the same as this property. The power of a product a times b is equal to the first factor raised to the exponent times the second factor raised to the same exponent. That is exactly what we are going to apply to simplify this part here. So let's carry that out. We copy the 1, and we rewrite the quantity 4 times 5 all raised to x as 4 raised to x times 5 raised to x, applying this first property here. And apply the same property to simplify the denominator. Now for the right side, the form of this is exactly the same as this second property here. When you have a raised to m all raised to n, we can just copy the base and multiply the exponents m times n. But since multiplication is commutative, we can also interchange the order of m times n to become n times m. And so, these two exponents here, m and n, can also be interchanged. That is what we are going to do in this right side. We are going to write 5 squared raised to x as 5 raised to x raised to the second, and do the same thing for the denominator. Take note that we switch the exponent 2 and x to make it x and 2, both for the numerator and the denominator. The reason behind that is we're going to convert this into an equation that is quadratic in form. But first, let's simplify this. We have here a common factor 4 raised to x in the numerator and 4 raised to x in the denominator, so we can cancel that out. And so we arrive at this equation now. We copy the 1, the second term becomes 5 raised to x over 4 raised to x, and we copy the right side. Now let's recall another law of exponent. When we have a fraction a over b raised to an exponent m, that is equal to the numerator raised to m over the denominator raised to m. We can use the converse of this rule in order to write 5 raised to x over 4 raised to x as a fraction raised to an exponent. And so, we first copy 1. This 5 raised to x over 4 raised to x is now written as a fraction 5 over 4 all raised to x, applying this property, and do the same thing at the right side. This 5 raised to x over 4 raised to x is now written as 5 over 4 raised to x, and applying the same property the second time, we now have this exponent outside. Now, let the quantity 5 over 4 raised to x be equal to certain variable r, then this right side would be equal to r squared. And so this equation now can be written as, we copy the 1, we let this term be equal to r, then the right side becomes r squared, because this is our r, which is our term inside, all raised to the second power. Now this last equation is a quadratic equation. So solving this quadratic equation for r, we'll write this first in standard quadratic equation, where the right side is equal to 0. And applying now the quadratic formula, we found that r is equal to 1 plus or minus the square root of 5 over 2. That's for the value of r. But notice that r is equal to 5 over 4, which is a positive base raised to a variable exponent. No matter what the value of x here, we cannot get a negative value for r. And so we'll ignore this minus sign because that will give us a negative value for r, and we'll just accept r equals 1 plus square root of 5 over 2. Now from these two statements, we now have 5 over 4 all raised to x equals r, and r is equal to 1 plus square root of 5 over 2. This is now the equation that we can use in order to find the value of x. Let's get the natural logarithm of both sides. So we now arrive here at ln of the left side equals ln of the right side. Now applying properties of logarithm, because ln is just logarithm to the base e, we can now write this as this exponent x times ln of 5 over 4, and then copy the right side. And solving now for x, we divide both sides by ln of 5 over 4. We now have the value of x. And so the value now of x that satisfy this original equation is x equals ln of this golden ratio 1 plus square root of 5 over 2 over ln of 5 over 4. And this problem is now solved. So thank you very much, and we'll see you in our next video. Bye for now.